We'll begin the module content in this video clip. If you haven't yet viewed the introductory video or read through Perloff chapters 1 to 3, please be sure to do that. In this section, we begin looking at consumer choice. The prescribed reading is Perloff's chapter 4. We take a closer look at the theory underlying the idea of a demand curve. Some of the concepts will be familiar from Micro in Economics 101. We'll build on those and add some new ones. This is a section in which you'll probably find it very helpful to draw on your own experiences as a consumer. After all, you've spent money and you've got expert knowledge on a consumer's decision-making process already. You'll see the theory is actually very sensible. Our analysis of consumer behavior is underpinned by three basic ideas. Individuals make choices based on their tastes or preferences or priorities. Consumers have to make those choices because they are constrained by limited income. So consumers try to maximize their well-being or the pleasure they get from consumption, subject to the constraints that they face. We're not going to go further into what determines their tastes or preferences. There may be a range of personal factors, and we'll leave that to the psychologists and sociologists. So we simply take preferences as given. We do make three important assumptions about the properties of consumer preferences. The first one is that of completeness, and that simply means that when facing a choice between any two bundles of goods, a consumer can always rank them. So the consumer would always be able to tell you which bundle they prefer, or that they're indifferent between the two bundles. So the consumer may prefer the first bundle to the second, or the second to the first, or regard them as being interchangeable, being equally desirable. In this case, clearly, the first bundle is preferred by this particular consumer. The second property is that of transitivity, which simply means internal consistency. So a consumer's preference over bundles will be consistent throughout. That means if a consumer prefers bundle A to bundle B and prefers bundle B to bundle C, it must follow that she also prefers bundle A to bundle C. Note that Perloff uses the term weak preference, and that simply means that if bundle A is weakly preferred to bundle B, it's at least as desirable as bundle B. It's like greater than or equal to. The third property is that of non-satiation, or to put it more simply, more is better. And that just means that more of a commodity is always preferred to less of it. That means we are talking about goods rather than bads. So a good would be a commodity for which we'd rather have more than less, as opposed to a bad, which could be something like pollution, where you'd rather have less than more. So looking at those two bundles, we could definitely say that the bundle on the left would be preferred to the one on the right, simply because it has more of both apples and bar ones, reflecting the assumption of non-satiation. We can use these three properties to say more about consumers' preferences, which we can summarize graphically as a preference map. Before we look at the graphic representation, let's briefly define the new concept we're going to be looking at, and that is an indifference curve. An indifference curve shows the set of all bundles of goods that a consumer regards as being equally desirable, or all the bundles among which the consumer would be indifferent. An indifference map can be used to represent the whole set of the consumer's tastes or preferences over those goods. We're going to take a simple example of a student, Lisa, who spends her income on two goods, pizza and burritos. By the way, this is one of those rather American examples that I mentioned in the introductory video. In case you're wondering, a burrito is a popular type of American takeaway, very similar to a wrap or a roti. We can go on to develop a simple model of our consumer and her choices over two goods over the semester. So we can plot burritos and pizzas on a set of axes. Bundles D and E show possible combinations of the two goods that Lisa might consume. Which of those two bundles would Lisa prefer? Think back to our properties of her preferences. Yes, she would definitely prefer bundle E because E has more of both goods than bundle D. In fact, she'd prefer bundle E to any bundle in the pink shaded area B. What about bundle F? She would also prefer bundle F to bundle E for the same reason. It has more pizzas and burritos than bundle E. And again, for the same reason, she'd prefer any bundle in the green shaded area A to bundle E. What about bundles A and C? Well, we can't say for sure how she'd feel about bundle A relative to bundle E because although it has more pizzas, it has fewer burritos. Likewise, bundle C has fewer pizzas, but it has more burritos, so we can't be sure without knowing more or asking Lisa about her preferences. Let's suppose we asked her and she said that she regards bundle C, E, and A as being equally desirable. In other words, she might say she's indifferent between bundle C, E, and A. In that case, redrawing the diagram in the right-hand panel, we could draw an indifference curve over those three bundles. Because remember, an indifference curve tells us all the bundles, all the combinations of goods among which the consumer would be indifferent, or which the consumer would regard as being equally desirable. So curve I1 is our first indifference curve, and it tells us that Lisa regards bundle C, which looks like 25 burritos and 15 pizzas, as being exactly the same in terms of her preferences and how desirable she finds the bundle as bundle E and as bundle A. She would be indifferent amongst those three. She wouldn't really care which one you gave her. She regards them all as being equivalent. What about bundle F? Well, we already know that F is preferable to E because it has more of both goods. So F must lie on a higher indifference curve. There's indifference curve I2. Because we know that F is definitely better to E or definitely preferable to E, we can also infer that F must be preferred to C and A because we know that E is equivalent to C and A in Lisa's eyes. And if we look at point D, that must lie on a lower indifference curve because we know that D would be less preferred to E. We can highlight some properties of indifference curves based on this analysis. Firstly, bundles on indifference curves that are further from the origin are going to be preferred to those on indifference curves closer to the origin. Think about why that would be the case. Think about bundle F compared to bundle E. Well, the bundles on the curves further from the origin have more of both goods. So the further the indifference curve is from the origin, the more preferred those bundles are. Secondly, an indifference curve can be drawn through every possible bundle. And that arises from our assumption of completeness. Remember, we assume that consumers can tell us exactly how they feel about any two sets of bundles. They can say, I prefer A, or I prefer B, or I regard them as being indifferent. Thirdly, indifference curves cannot cross. You'll never see crossing or intersecting indifference curves. And fourthly, indifference curves slope downwards. Let's look at some impossible indifference curves just to better understand the reasons behind properties 3 and 4. Figure 4.2 shows us 3 options of impossible indifference curves. Let's take them one by one. Firstly, intersecting indifference curves. Can you see what the problem is with this diagram? Well, Lisa is indifferent between bundle E and bundle A according to indifference curve I0, the blue indifference curve. But according to the pink indifference curve I1, she's also indifferent between bundle E and bundle B. So by transitivity, remember that means internal consistency, she should also be indifferent between A and B if they're both equivalent to E. But that's impossible because you can clearly see that B has more of both goods. so B must be preferred to A. So logically, crossing indifference curves are just impossible. What about upsloping indifference curves? Can you spot the problem with this indifference curve? Well, it would tell us that she's indifferent between bundle B and bundle A because they're on the same indifference curve. But clearly, B has more of both goods, so that contradicts the more is better assumption. And again, an upsloping indifference curve is just not possible. Finally, we have a thick indifference curve. Can you spot the problem with this one? It's telling us that the consumer is indifferent between bundle B and bundle A. They're on the same indifference curve. But again, you can see that B has more of both goods, so B should clearly be preferred to bundle A. To end off with, you can test your understanding and knowledge by trying this multiple choice question. The principle that more is better results in indifference curves: A, sloping down, B, not intersecting, C, reflecting bundles that are preferred the further they are from the origin, D, all of the above, or E, none of the above. You'd be right if you said that. All of those are correct. All of the above options arise from the more is better assumption. In the next short video, we'll look at the curvature of the indifference curve and what that tells us.